Hello everyone, Future Coder here. So before we get into today's video, I just want to give a shout out to a good friend of the channel, Engineering Scale Models. Engineering Scale Models, or Jason, which is his real name, is a very active member of the community and a very good friend of the channel. He's sponsored the channel before by sending us gifts, and I want to do him a favour by trying to get him to 1,000 subscribers on YouTube. And the reason for that is not because you can monetize at 1,000 subscribers, but purely because he wants to be able to get the community tab. And he wants the community tab option so as he can post links to all of the files that he's making based on the Nintendo Switch, such as the pinouts for the USB-C port and all of the diode readings for all of the chips and things like that. So if we could get him to 1,000 subscribers so as he can actually use that feature of YouTube, that would be absolutely fantastic. There'll be a link in the video description. Just head over there, hit subscribe, and that is all you need to do. But without further ado, let's get into today's video. Oh, and don't forget to subscribe to me if you're new. Thanks. Hello everyone, welcome to another repair video. Today we're going to be working on this Nintendo Switch. This has been sent in because it has no power, and if we take a look at the ticket that was sent with it, it says no power with a charged battery. So this one is going to be a rather interesting one, and usually when we get no power with a charged battery, we've either got an issue with the USB-C circuit or we've got an issue with the M92 or the P13. So it's going to be quite interesting. The first thing I'm going to do though is just have a look at the port, and I've got a feeling this needs a port. I can see a couple of pins, I'm pretty sure they're sticking up. Let's have a look under the microscope and see what the port looks like. And yep, I can see some pins sticking up there, so there's definitely going to be a charging port needs replacing. You'll have to excuse the shaky hands. To be able to do this, I have to hang the microscope over the edge of the table, and oh dear, that doesn't look good, does it? So we've clearly got some broken pins, but the port itself is it's kind of hanging out there, to be honest. It's just chilling out inside, not attached to anything by the look of that. This might be a trace repair job. Okay, so let's take it apart then. I'm not going to try and turn this on because there's kind of no point. This might get interesting. Let's just put it that way. This might get interesting. So I'm going to start off by disassembling it. I'll fast forward through this process, but while I've got your attention, if you are new around here, don't forget to hit that subscribe button, and if you're enjoying this kind of content, be sure to hit that like button as well. Okay, so a little bit of dust bunny there, that's fine. Right, so I'm going to pop the rest of the housing to one side. Let me just take a look at what's going on with this, and I'm not sure actually. I think it's probably just a metal frame. I'd say it's probably just a metal frame what's broken. I don't think it's the actual port itself. Okay, well, that should be okay then. Either way, that port needs changing because the charge port is definitely damaged. 100% that charge port is damaged. So what I'm going to do is I'm going to remove this charge port that's on here at the moment, and I'm not going to put another one on until the end of the repair. So I'm going to remove it just in case there's some pins shorting out inside or something, and that could be stopping it from turning on. So I'll get that removed first and foremost. So I don't have a suitable board holder for the Nintendo Switch at the moment, so I'm just going to use my solder, and I'll do it that way instead. So what I usually do with the ports is to hold the port while I'm heating up until I start to feel it move around. So I hold the port with tweezers, put some hot air into it, and then wait for it to start moving around before I actually go ahead and remove it. Okay, I've just felt it drop, so I'm going to give it another few seconds. and then I can lift it off safely without doing any kind of damage to the traces. So any damage that's on them traces now would be down to the fact that the port was broken. But there's the old charger port off. That definitely needs replacing at some point. And I can see a few pins still stuck to the board itself. Let's go under the microscope and I'll show you. Okay, so if we take a look here, then we can clearly see that we've got 3 pins still stuck to the actual port itself, or stuck to the area rather. The reason for that is because the board was snapped, the port was snapped. This dark looking stuff here, don't worry about that. That's not torn traces. That is purely just oxidization. So what I'm going to do is I'm just going to replace the solder on here and just clean everything up. And the way I'm going to do that is just to run the soldering iron with some leaded solder over it. And I'm just going to clean it up. I'm not going to bother replacing the port yet. Okay, so you see where I touched them and those pads came straight back. So I'll go around in a circular motion. And there you go. That's nice and clean. It's not perfect. I am going to touch it up a little bit. It's definitely not perfect, that's for certain. So one thing I don't recommend is using low melt solder, especially on a Nintendo Switch USB-C port. The reason for that is because we don't know when those bottom pins are going to be melted, and we can't actually access those pins to put low melt on. So I do not recommend using low melt solder on a Nintendo Switch. Some people would, but I don't personally recommend it. Right, so we've got one of the legs stuck inside here. So the good thing about the Switch is it's a very thin board. Right, so I'm just going to try and extract this leg here. There we go. Perfect. So I've got that leg out. Okay, so that's cleaned up. So I know now that that port is not going to be causing a problem. So now I can carry on with some testing. So I'm just going to clean up the flux off there before it dries up. So that looks perfect now. Looks absolutely beautiful now. So I know I've got no issues with the port. That's good. That means I haven't got to do any trace repair. Okay, so I'm going to start at the very bottom with the testing. So the first thing I'm going to test is, I know that the port is no good because obviously we've just took it off. But the first test I'm going to do is going to be on this fuse here. This fuse here basically controls power coming in. And if we get a problem with the voltage in line, so this pin here or this pin here, then what can happen is this fuse can blow. This is a 3.5 amp fuse. It's a fast blow fuse, so it blows very, very quickly if there's an issue, and usually prevents damage to the circuit. Not always, but it does sometimes when we've got some sort of short on the main voltage in. So what I'm going to do, I'm going to set my multimeter into continuity mode. That's the mode that's going to beep when we complete the circuit, and I'm going to test from top to bottom of this fuse, and the fuse is good. Okay, so the fuse is fine. So the next thing I'm going to test is going to be this filter here. I'm just going to check for continuity from top to bottom. We should have continuity from top to bottom. And those filters are good. Now let's check from left to right. And that's fine. Okay. Right, so I'm just going to brush some of this dust away. It's quite dusty here. So, certainly seen some use this switch has. Right, so next I'm going to test these MOSFETs in the middle. So this array of MOSFETs here, I'm going to pop one probe on ground and I'm going to check the input side of these capacitors. Including this big one here. and they appear to be good. Okay, so then I'm going to work up. I'm going to have a look at M92T36. This is the power management IC for the Nintendo Switch, and this controls everything, absolutely everything. So usually when we get power issues on the Switch, it's because of this chip. So I'm going to pop one probe on ground, and I'm going to check the chip by testing the capacitors around it. So these four here are directly linked to M92T36, same as the two that are on the side here. There's one here, I can't remember if it's this one or this one, but there's one here that is linked to P13 USB, which is the video output IC on the back of the board. I'll show you that in a moment. But one of these is related to the P13 USB. So input side of these is on the bottom. No shorts. Right hand side, no short. Let's check one side of these resistors here as well, and we get no short there. Let's check the bottom of this one and the bottom of that one. Good. Check the bottom of that one, top of this one, and we have a short there, and the bottom of this one. So we have a short here. I think this is the one that's related to P13 USB. So before we go any further, then I'm going to flip the board over, and I'm going to have a look at P13 USB. And that's just a bit of flux off my table. Ignore that. I did just have to fix my USB amp meter, so there's a bit of flux on my blue mat. So that's nothing to do with the customer. That is purely flux from my table, and also from the fact I've just removed the port as well. So I'm just cleaning that up, and you can see that's a factory chip. There's nothing wrong with that at all, or nothing's been changed on this board at all like that. So let's test the top cap for continuity. And I've got a feeling it's going to be shorted. Yeah, I've also got flux on this chip as well. I'll clean up properly before I put it back together anyway. And there you go. So that capacitor is shorted. Obviously we shouldn't have a short on both sides. And that is usually directly related to M92 to P13 USB. So I'm going to remove the chip rather than removing the capacitor, because it's normally the chip what goes bad. Usually the capacitor doesn't go bad unless there's extreme circumstances. So I'll remove the chip, and then I'll test again, make sure that short's gone. If the short's gone, I'll replace the chip, and fingers crossed we can get it working. Okay, so there's the P13 chip removed. So now let's test again. Let's pop one probe on ground again. In this case I can use the centre pad. And short is gone. So we've got a short one side, which is normal. Short is gone. I'll just show you this. So P13 is definitely bad. Okay, so let's get P13 changed. Let's put a new P13 on. Okay, and in the direction I'm in the direction I'm facing right now, pin number 1 is in the top right hand corner. That's indicated by this arrow here as well, by the way. Right, so I'm going to turn my airflow down to 30%. My hot air is set to 420. Okay, so that's tacked roughly in place. So I always tack it down first before I add flux. Just stops it from sliding around. And now I'll increase my airflow to 50%. And we should see that put itself in a second. There we go. Perfect. So now I'm going to press and hold, and I'm going to solder it again. Press and hold. And we do get a bit of squeezing. So the reason we press and hold is to make sure that it's firmly flat to the board, as flat as it can possibly go. And it squeezes out any excess solder as well, so always want to push down and make sure that it's soldered correctly. I'm just going to clean this up. I'll just run my soldering iron across all of the pads, make sure we've got no bridges. Okay. I'm not going to run across the back ones because they are rather difficult to get to with a soldering iron. But I shouldn't need to anyway. I'm just going to give it another reflow before I call the chip done. And there we go. Okay. So while I'm here, I'm going to test these filters down below the chip. Because sometimes when we have an issue with P13, these filters will blow. And that will prevent any kind of signal from passing through. So I'm going to test these. And it's usually filter number 1 or filter number 2 which goes bad. If they go bad. So multimeter in continuity mode. Good. 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 Okay. So that seems fine now. Let's just check this cap and make sure that the short is gone. And that appears to be gone. Let's check for a short to ground. And good. Okay. Right, so let's flip the board back round then a minute. I just want to finish the inspection. And I'm going to carry on with checking this coil. So this coil needs to have continuity across it. It's one that's trolled me a couple of times now. So I always check this before I do anything else. The coil is good, we've got continuity. So let's pop a probe on ground again. And let's test BQ. No short. So BQ is the battery management IC. No short. That's ground. No short. No short. And no short. Excellent. So it doesn't appear to be any more issues. So what I'm going to do is I'm going to pop this back in the housing just temporarily, just to test and see if it comes on with the battery. So let's get the housing back. And all I'm going to connect up is the power button, the battery, the LCD and the backlight. That's all I need to be able to test. So I'm not going to test it with the customer's battery because I don't know the current status of that battery. So what I am going to do is I'm going to get my own battery, which I know is 100% charged, and that way then I'll know whether or not it's going to turn on. Just removes one more variable because the chances are the customer's battery is going to be dead. I can show you how we can test that as well. Okay, so if we plug the customer's battery in and then we take the multimeter, we put the multimeter into voltage mode, DC voltage, and then we put one probe on the ground terminals of the battery, which are the black wires, and the other probe on the red wires, which is the positive, and we get 2.5 volts. That is incredibly flat, and that's going to take a long time to charge. So I'm not going to be doing testing with the customer's battery because that's going to take far too long. So what I will do is I'll take my own known good battery, which I know is full, and I'll test it with that. So here's one which I know 100% is full. So if I just probe this one now, this should be at 4.1 volts. I tested this last night, and this battery should be at 4.1 volts. 4.11 volts, yeah. So that battery is around about 95% full. So I'm going to test it with this one. The way I'm going to do that is by taking the customer's battery out, and then I want to just connect up this battery. So what I'm going to do, I'm going to untwist the wires there, and then I'm just going to plug this in just like that. I'll plug it in like that, and then if I plug the power button in as well, a power button in, and now by flipping it around, so if I flip it around like this, keeping the battery connected, I can try and turn this on. And there we go. So that's turning on. Let's just see if it loads up to the dashboard. Sometimes we can end up with a blue screen after an issue with the charging circuit. And that's it. So that battery is on 100%, as you can see. So that is absolutely perfect. So now all I've got to do is change the charging port, or put a new charging port on, and then this job's done. Nice easy repair there. I've been recording for 36 minutes now, and I've been discussing a lot about what I'm doing. So yeah, it's not a bad repair. So all in all, with testing, you're probably looking at, if you're not talking about it on camera, you're probably looking at around about 40 minutes, even for someone with not that much experience. Me personally, I think it takes me around about 25 to 30 minutes maximum to do a charging port and one IC. Okay, so I'm going to hang this over the edge of the table now. So I'm going to move my bench, or rather my blue mat. I'm going to take a brand new port. That one I don't think is brand new. I think that's a donor board pull. So I'll use some brand new ones. There we go. Brand new port. And what I'm going to do first, before I go ahead and put this port on, is I'm just going to tin the pads. And by doing this, it's going to make sure that it gets a connection. I'm just going to pop a bit of solder onto the edge of my tip. Melt that flux. And just tin them pads. So I'll get rid of that solder bridge in a second on the one side. Just clean off the tip. And there we go. So that there is perfectly tinned, ready to be dropped onto the customer's board. So let's just go over to here where we can see the board. And I'm going to swap to a bigger tip for a minute. Reason for that is because I want to clean out those holes there. Let's add some fresh flux. And then I'm going to wick the solder away. I at least want to get rid of the majority. Actually, let's retin these pads first, shall we? Before we go any further, let's make sure these pads are all nicely tinned. We want to make sure they're all even, just to ensure that we're going to get a good connection on those bottom pads. The top pads not so much, because we can solder them afterwards. Okay, so I've just got a little bit of excess solder on the ground pad there. So let's just clean that. Okay, so I'm ready to drop this port on now. So what I'm going to do is I'm going to add some flux to the area, including the ground legs, and then I'm going to take the nozzle off my hot air station. So I'm going to use the atom without a nozzle, and I'm going to leave the airflow at 30%. I'm going to set the hot air to 450 Celsius, and then I'm going to grip the charger port itself with my tweezers. So I'm going to hold the charger port with the tweezers, just like this, and then I'm going to heat up the entire area using the hot air station until I feel like it's actually melted the solder that's on there. Okay, now I'm going to drop the port on while keeping the heat there. So I'm going to press and hold, and then I'm going to let that settle. Okay, so now what I'm going to do is I'm going to knock the airflow up to 50%. I'm going to add some more flux, and then I'm going to reflow it once more. Press and hold on the port. And release. So the port should be in the right position. Let's see if it's actually soldered. And it looks perfectly aligned. Alright. So what I'll do then is I'm going to angle the board so that we can see better, and now I'm just going to swap back to my small tip, and I'm going to touch up every single joint, or at least the ones I can get to, and then hope that the bottom ones are soldered. So I'll add some more flux there. I'm just going to come in and tap on every single joint. Okay, so I've got a couple of solder bridges which I'll get rid of. Just clean off the tip of the iron so there's no excess solder, and then I can just use the drag method. Okay, so let me clean up, and then I'll take a look and see if there are any more bridges. If there are, I'll deal with them. But hopefully that should be done. So if you're wondering what I'm using here, it's isopropyl alcohol and a cotton swab just for cleaning up. Okay, so we do have a few pins not soldered, so let me just get them sorted. Right, so I think that should be done. Just needed a touch up there. Right, so what I want to do then is, again, I want to make sure it still turns on. But the main thing I want to do is check and see if it charges. So I'm going to use my own known good battery, the one that I know is 100% charged. I'm going to charge it up, or rather I'm going to plug it in, and then I'm going to see if it charges. So let's just try and turn this on. Turns on, okay, good. Alright. So I'm going to use my USB amp meter now to see what kind of current it draws. Should be expecting around 0.46 amps to 1.46 amps, depending on whether it's fast charging or not. And let's have a look. .73 amps, 1.2, okay, I'm not getting the charging symbol for some reason. Right, I'll tell you what we'll do. Because it's saying that it's charging according to the amp meter. So I'm going to unplug that. And I'm going to plug the customer's battery in. Right, so I'm going to plug the customer's battery in then. And I'm going to leave this to charge for a little while. So I'm going to grab the official charger, the 15 volt charger, and we'll see what it works. So this is the official Nintendo Switch charger, rather than a third-party one. And that's not working. Right, well, there could be something wrong with my charger. Right, but it's saying on my other amp meter that I'm drawing 1.10 amps. And it is powering it off the charger. So there's no battery connected to that at the moment, or there wasn't. And it was powering it off the charger for a second. So let's see if it comes up with a charging symbol. No. No, it doesn't. Yes, it does. Right. That's coming up with a charging symbol there. and it's saying right now that I am drawing 0.31 amps. So if we take a look, just there we've got 5.01 volts, 0.31 amps. So let me flip the charger around and see if it does that the other side. So 0.00 amps. Nope. So it's only charging one side. So what I'm going to do, I'm going to leave this. Actually, let me try my official Nintendo Switch charger now. No. So what I'm going to need to do is reflow that port. The port's not on correctly, but I want to charge it first, and I don't know why my charger's not working. It's a brand new charger. It's a brand new charger. Right, it's charging that side. Okay. It's charging that side. So I'm going to let this charge up on the 15 volt charger, on the fast charger. I'm going to let this charge up for 20 minutes, half an hour, until it actually turns on. And then I'm going to take the board back out and I'm going to reflow that port. And if I have to, I'll put another port on it. The cheapest chips. I'll put another port on if I have to, and hopefully get it working both sides. Right, okay, so this is charged up to 28% now, so I don't think it's working on the other side though, so I'm going to reflow that port and see if I can get it working on the other side. So what I'll do now then, I can use the customer's battery now because I have charged it up enough to know whether or not it's going to charge. So what I'm going to do is I'm just going to plug it in. Just see if it draws anything. Okay, we get 0.45 that side, and that's pumped up to fast charge that side. So ignoring the all of the junk on my desk, it's been a very busy week. Right, so I'm unplugging that now. Should see 0 amps, and let's flip it around. Still 0 amps. So no charge on the other side. Right. Okay. Right, so let me just have a look then at whether or not we get voltage on the fuse. So one probe on ground. And we are getting 4.9 volts. 4.968 volts. Let's flip the charger around. So, flip round. Just going to untwist that a little bit. And let's check again. Same place. Whoops. .8, so it's charging that side, it's not charging the other side. That's telling me that there's an issue with M92. So M92 is the power management IC, and I've got a feeling that M92 is bad. So let's replace M92 then. I'm going to use the same heat settings. So 450 degrees Celsius and 50% airflow. Okay, so M92's off. Grab a replacement. So pin number 1 in the orientation I've got at the minute is in the top left hand side, closest to the shield for the CPU. So I'll do what I did with the P13. Just tack it in place, then I'll add some more flux. And it should put itself into place. There we go. Press and hold. Okay. So now I'm going to clean up the solder joints, make sure we've got no bridges, get rid of all of that excess solder that squoze out from underneath the chip. These chips that I buy from AliExpress come with solder already on the pads because, well, according to the manufacturer, they get tested, which is why they've got a black mark on them, because they mark them off once they've tested them. It's either that or they've tested them because of them donor pulls. Okay, so I'm just going to clean up. Okay, and I do have some solder that's leaked out onto these caps. So it looks like I'm going to have to wick that away. Right, that's not wicking away. So the way I deal with that is to just remove one of the components. So I'll remove one of them components for a minute. And now I should be able to just drop that back on. So at the moment it's stuck to my tweezers. So the way I do that is by removing the component using hot air and then moving the tweezers out of the way and letting it cool down without the hot air in place, and then the component will stick to one end of the tweezers, or most of the time it will. Okay, so I apologise about that going out of focus there. The map was starting to expand. And that looks good, looks fine. Okay, I'm not going to bother cleaning it because I'm going to run it under the ultrasonic, run it in the ultrasonic cleaner afterwards. There we go. Okay, so there's the old chip. Okay, right, so let's just pop it onto the battery again. I'm not going to bother connecting anything else up like the LCD. Just want to see if it charges now on both sides. .43 amps that side. Yes, it's charging both sides. Right, so that about wraps it up for this video. So let's just summarise on this one then. So this one was sent in because it had no power when it was connected to a charged battery. So first thing I noticed was the fact that the charger port was damaged. So the charger port got took off just in case the charger port itself was causing a short on the charging circuit, and it still didn't have power with a non-good battery. So I done some tests around M92. M92 originally didn't show up as having a problem, but the P13 USB did. So I replaced that, and I also replaced the charger port as well, and the console turned on and it seemed to work absolutely fine until I attempted to charge it. When I attempted to charge it, it turned out that it was only charging one way. Which wasn't down to my installation of the port, it was down to the fact that M92 was indeed bad. So it's a common knock-on effect when the charging port is damaged. The pins become shorted out, and that causes power to go where power is not meant to go. It causes data to go where data is not meant to go, and it knocks out several chips, or one of several chips, or even all of them. So it can knock out BQ24193, which is the battery management IC. In this case it didn't, and we knew that because it was turning on with a battery. And it can also knock out M92 and P13, which in this case it did. So this has had the charger port, M92 and P13, which is quite a big job to do. It's quite a lot of collateral damage considering it was just for a damaged charger port. But that's going to be it for this video. Thank you very much for watching. If you do have any comments or questions, leave them down in the comment section down below. As always, if you enjoyed the video, give it a thumbs up, and if you want to see more repair videos, be sure to hit that subscribe button and turn on bell notifications so that you're notified every time that I upload. I also now have channel members, where for just as little as £1.99 a month you can support the channel, and all channel members get early access to my videos. But that's going to be it for this video. Thank you very much for watching, and until next time, I'll see you later. Bye for now.